Welcome to the last podcast episode of International Voices in 2020. I'm your host and moderator, Udo Fluck, and I have the honor to oversee the Office of Global and Cultural Affairs in Arts Missoula. This is the 11th podcast this year. We started in February. To listen to the previous 10 podcasts, please visit artsmissoula.org. Click on Global and Cultural Affairs and visit Radio and Podcasts. International Voices is a monthly podcast brought to you by Global and Cultural Affairs of Arts Missoula and The Trail 1033. For the last podcast in 2020, I would like to welcome Dr. Ulrich Kamp as my guest. He is an international voice, born, raised, and educated in Germany. Ulrich received his Master's of Science at the Freie Universität in Berlin and his PhD from the Technische Universität in Berlin in geomorphology. Ulrich has held academic positions and fellowships in Germany, Mongolia, and the United States. He has done research in Algeria, India, Jordan, Lesotho, Mongolia, Pakistan, Peru, South Africa, and Venezuela. He taught at the University of Montana's Department of Geography from 2005 to 2018 before accepting a research and teaching position at the University of Michigan in Dearborn, where he currently is Professor of Earth and Environment and Chair of the Environmental Studies program in the Department of Natural Sciences. He is a glaciologist with an interest in environmental studies and climate change. Climate change is one of the defining challenges of the 21st century, along with global population, poverty alleviation, environmental degradation, and global security. The problem is that climate change is no longer just a scientific concern, but encompasses economics, sociology, geopolitics, national and local politics, law, health, societies, and cultures, just to name a few. My conversation today has the focus climate change and its impact on societies and cultures. And so without any further ado, let's jump right in. Ulrich, taking into consideration where we live, listeners in Missoula and surrounding area are familiar with glaciers, but I'm not sure if many people know what a glaciologist does. Can you please define for us what a glaciologist is and does?
Yeah, Udo, thanks for having me. So when we look at the term glaciology, so it literally means the study of ice. So a glacier is a larger mass of snow and ice that moves downhill under the influence of gravity. So the gravity pulls the ice mass down the hill. And in that moment, by definition, we would talk about a glacier. So glaciology, that's my field, right? It's a part of geosciences.
Right.
It is interdisciplinary in nature. And so we combine other fields to study glaciers like geology, that I also studied as a student, geochemistry, meteorology, climatology, and then my specialty, geomorphology. So I'm actually a glacial geomorphologist. I'm interested in glacial landforms and landscapes. And of course, you know very well Glacier National Park, right next door. Right. So that's the best example for a glacial landscape. And today, glaciology is also concerned with the impact of glacial changes and then related changes in, for example, available meltwater, on local communities,
right,
and even regional societies. So, so a glaciologist, what I'm also is a scientist who studies then, generally ice, particularly glaciers. And I use field methods and remote sensing methods. So that would be the use of satellite data to analyze these landscapes. So the field methods, so when I travel and go into the field, that would include, for example, retrieving ice cores from boreholes. So we can really read the ice layers like a history book, right? Because every winter, again, it snows, right? And it all piles up, and then you have these thin layers, and that it's like pages in a history book, and you can read in that book. So then we can learn about the ice composition, for example, about its density, about its age. We can date it. And the deepest ice core records are actually from Antarctica in Greenland, and they are, I think, up to 3 kilometers deep. So what is it? It would be something a little bit over 2 miles. The oldest ice core record is from Antarctica, and it dates back at least 800,000 years. So we can read into the history of our atmosphere, by looking at the composition, the chemical composition in the ice that is 800,000 years old, and reconstruct how the atmosphere looked like in those days. And the carbon dioxide concentrations, for example, have never been as high as they are today for the last probably 1 million years.
Right.
And then I also use satellite data. That's actually my main field. And we, for example, can identify, the glacier's velocity. So how fast is the glacier moving down the valley? That gives us an idea about the budget of the glacier.
Right.
Or we can identify, under the impact of climate change, the glacier is melting, and then we can identify nowadays meltwater lakes on top of the surface of the glacier.
This is really helpful, Ulrich, and I appreciate the definition of the field and what the person actually does. And I would like to, before we get deeper into the material, I think it would be helpful to have some clarity about some basic terminology, if you don't mind. What's the difference between climate change and global warming?
So, yeah, that's a really good question, because it's, I think the terminology is somewhat confusing and sometimes used in the wrong way.
Right.
Particularly in the mainstream media. So first, I think it's necessary to understand that climate is always changing, and it always changed in the past. When we go back and look at the 4.5 billion years of Earth history, the climate always changed. So that is what we call natural climate change.
Right.
And it will also change in the future. So when we use the term climate change today in science, in the papers that we write, and also in the media, we are referring to a change of the climate that is an anomaly from the natural variations. So what that means is it's actually on top of the natural climate change, there is a human-triggered climate change. So the human impact from, let's say, the burning of fossil fuels, from large-scale industrialized agriculture, and they all release, large quantities of greenhouse gases in the atmosphere.
Right.
But important now, the term climate change goes beyond climate itself. So it refers to all current environmental changes that are all a consequence of human-triggered climate change.
So it's not one thing, it's a sum of many things.
Exactly. So it's not only the climate. So all the environmental changes. So for example, what I'm concerned with, the accelerated melting of mountain glaciers, or the melting of the ice shields on Antarctica and Greenland, or sea level rise, or the shift of agricultural zones, earlier blooming times, and so forth. So all of this is part of climate change science. So now global warming, that is pretty simple. That's a part of climate change, and it focuses on the increase of the average air temperature.
So we could say that the two are connected, but they're not the same.
Exactly. So climate change is much larger. It's an entire field that we study, and the global warming is simply looking at the temperature records.
Okay. So then my next question is, in establishing this base here, do scientists agree on climate change?
Well, that's also a very important one that I often discuss with my students. So that this is very clear. So more or less all scientists globally are convinced that human-triggered climate change is happening. I cannot even think about any of my colleagues anywhere on the globe who would question that this human-triggered climate change is going on. So why is that? Because, scientists are not believers. So science is not a religion, right? So science is about knowledge. And so what we do as scientists, we apply the so-called scientific method. So first, in the beginning, you have a hypothesis. So, for example, I could have a question: why is the sky blue? And then to that question, I already have an answer. That would be the sky is blue because someone painted it blue. Or another hypothesis would be because particularly the shortwave radiation and the blue light of the visible part of the light is scattered in the atmosphere into all directions, and that makes the sky blue. That would be my hypothesis, the potential answer to the question.
Right.
So now we have to test it. We run experiments. We go out into the real world and we observe, for example, temperature increase. And then, we collect data. So these are the scientific facts, not alternative facts, scientific facts. And we analyze them and interpret them. And then either our results and conclusions support the hypothesis or dismiss the hypothesis. And as scientists, we are not really interested which of them is really correct. Important is that we find one of these two answers.
Right.
If many of these experiments and tests, and then particularly in my field worldwide, many research groups work on climate change. If hundreds and thousands of results and conclusions show that climate change is real, so in that moment it becomes a theory. And then, of course, we also look into the future. So we run sophisticated computer simulation, and based on what we know from the past and today, we feed our complicated algorithms, our softwares, and look into the future. So important is that climate change science is concerned with the past. So it's really based on analysis of collecting facts and then the present. So what's going on today?
Right.
And we only have to observe ocean temperature, right? It's measured.
Right.
And then we look into the future. So for example, so we observed that in the last, almost 150 years, so since the Industrial Revolution started, more or less, at least in the United States, there was an increase of global average temperature of 1 degree Celsius. So now you must tell me, well, I don't even feel, if it's outside, if it's 20 or 21 degree, I don't feel the difference.
Right.
So this is the average temperature of the entire Earth atmosphere. And 1 degree from what we know in the past in only 150 years. So that's a lot. So we could say that temperature is rising rapidly today. And I think we had the last top 5 hottest years ever observed, right, by scientists from 2015 to 2019. So actually the last 5 years were the hottest on the planet ever. When we look at, please.
This measuring, Ulrich, takes place, of course, on Earth, but you also mentioned earlier that you are working with satellites to track this. So what does NASA has to do with climate change?
Yeah, so NASA mainly monitors climate change from space, right? It's our space agency. is also, by the way, an important funder of climate change research. So any political decisions in Washington would have a huge impact also on how much funding is available, and am I able to do my research, right? I need money to do that.
Right.
So, and by the way, NASA is also the largest employer of climate scientists worldwide. So it's really the world leader when it comes to observing our atmosphere and land surface from space. So it also has a fantastic webpage, NASA Global Climate Change. Maybe the audience might go to and check it out.
Sure.
With lots of information for non-experts. It also offers educational tools and collaborates with US and international agencies to attack climate change with full force. So we are we're collecting data, again, from the atmosphere and then from land cover, from the ocean. We measured ocean temperature with satellites. And we have now records that in some cases go back to the early 70s, sometimes even the 60s. So there's a strong record of, again, very important observation. This is hard fact data that we can analyze. And of course, the satellites are becoming more and more sophisticated nowadays. And with some satellites, you can almost read your newspaper, right? When you're in your backyard. I could read the book, right, that you are interested in from space, more or less. So we have really a wonderful database available. And again, unfortunately, the overwhelming majority of the data tells us that story of rapid climate change that is going on right now.
Now, I would think that particularly when one looks at glacier movement, and you were talking about this when we started our conversation today, that having a view from space must help tremendously when looking at glacial movement, because you couldn't do it obviously standing next to the glacier so much, but you can do it really well when you look at it from top. Is that correct?
Yeah, correct. So it is possible also in the field. And of course, in the old days, scientists had only that option. Nowadays, we still do that.
Right.
At some reference glaciers around the world, because we still assume that the field measurements, so us being at a glacier and measuring, that it comes with a pretty high accuracy. And then we use these reference glaciers, to compare them with the satellite analysis.
Right.
And the better these results match, right, the more certain we are that our methodology, by looking at satellite data, works. So we could go into the field, and put some markers on a glacier. For example, it's pretty simple. You spray paint a boulder that is laying on the surface of the glacier, and you mark it, and you take the exact location with a GPS, and then you come back the other year, and the whole glacier moved down valley, and with it, of course, the boulder, and the boulder moved, 50 meters down valley.
Right.
So that would be a simple field method that you and I could do in Glacier National Park.
Sure.
And then you compare that with satellite data. But of course, so nowadays, and we have at least over 100,000 glaciers worldwide. Of course, it would be impossible to go into the field, right, and visit them.
Right.
So now we have international programs that are concerned with analyzing vast amounts of satellite data.
Now, this is fascinating, Ulrich, and just listening to you, I have to wonder, at what age did you know that you wanted to research glaciers?
Glaciers, as some people think, why do you look at ice, right? How did that happen? Life is unpredictable, right? But when I was a child and a teenager, so often, we are influenced by individuals in our lives, right? In our careers, we look up to mentors. They are very important. And when I was a kid and teenager, so one of my uncles, he actually worked for Volkswagen, And in those days, he traveled around the world to represent the company. And when he came back to our little village in Northwest Germany, he brought back artifacts and also maps from faraway places like Tahiti, right? And I was always laying in the living room on the floor and studying these maps for hours, and I can still do that. And then I dreamed about the world and other cultures and other people, and I really wanted to become Indiana Jones. Although I was from that tiny village. But on a side note, in Indiana Jones, as you know, in The Last Crusade, right, visited Petra in Jordan. And I visited Jordan and Petra 3 times. I walked in Indiana Jones' footsteps.
So there are a lot of parallels between Indiana Jones and Ulrich Kamp.
Totally.
Not even to mention the good looks.
I wished I would look like Harrison Ford, but working on it. So I then studied geography in Berlin, and was concerned with urban studies. I was interested in cities, and something strange happened. I joined my best friend, who also was a colleague, during this summer to the Hindu Kush Mountains in Pakistan. So that was a really interesting trip, and I totally fell in love with the mountains and its glaciers. And then when I came back to Berlin, I actually quit my job and found a job at the Technical University in Berlin and carried out my own PhD studies in northern Pakistan. So I went back and worked on paleoglaciations, so former glaciations in the Hindu Kush. So I think when I count all trips together, so I spent over a year in Pakistan. So since then, I'm studying glaciers, still doing it.
Okay. No, that's really interesting. I'm always wondering, how do people get started with their career? At what point do they know this is what I want to do? This is what I'm passionate about. So this is good to know that this was an early start that had to do with maps and the fascination of other places. And I think that connects well to my next question, and that is the impact of climate change on glaciers is probably not the same across the world. And you were just mentioning some of your travels. So the interest must be to look at if there are similar developments or if they are different depending on where one is. So are there regions or countries that are more impacted than others when we think about climate change and glaciers?
Yeah, so again, the database is huge, 100,000 glaciers. And of course, nature, right, is a dynamic system, and it reacts according to the regional conditions. So it's interesting. Many people believe that glaciers are shrinking, right, and receding everywhere on the globe. And we hear that in the media sometimes. All glaciers are shrinking. That's almost correct. So probably over 90% of the glaciers worldwide, as far as we know from our analysis, are in recession. For example, Glacier National Park, right? Next time you go, you can maybe start counting. So in the 19th century, Glacier National Park had 150 glaciers. And then when it was created, of course, the name comes from the glaciated landscape, but also from the many glaciers.
Right.
2010, only in 2010, we had 37 glaciers left, and the newest number from this year is 25. So from 150 glaciers down to 25. And the prediction is that by 2030, there might be gone, almost gone. So if you want to see a glacier in Glacier National Park, you have to take your kids right now. So what about the other 10% of the glaciers? Many of them are actually advancing. And the weird story is here that they are advancing because of global warming. So, this is why some climate change critics say that, scientists and the media, so this is all confusing. So are glaciers shrinking or are they advancing? And if they're advancing, then look, the climate cannot get warmer, right? Because the glacier needs cold temperatures.
Right.
Again, it's not that easy. So nature is more complicated. So for example, in the Karakoram, where I spent a lot of time, right, and analyzed glaciers in detail, that's a pretty famous area because one of my colleagues from Canada, actually came up with the term Karakoram anomaly. In that area, one of the highest mountain ranges on the globe, many of the glaciers are actually advancing. So now we can ask ourselves, okay, why is that? Why would some glaciers grow? So the climate is changing, the atmosphere is warming, right? We talked about that 1 degree in the last 150 years.
Right.
That of course means that more water from the oceans is evaporating into the atmosphere, right? So the atmosphere is getting increases in humidity, it's getting moisture, right? And we will look at more cloud developments in the future. Well, actually, we already have it. And these warmer oceans and that evaporated water vapor, that, for example, also feeds into hurricanes, right? And in the moment, we see that we have probably more hurricanes,
right,
but definitely more intense hurricanes. So they're getting larger and larger.
Right.
So in a way, the oceans feed into that system hurricane.
Interesting.
So coming back to the glaciers now. So when this moist air now, crashes into the Karakoram Mountains because of their elevation, the moist air has to make it over the mountain. So it's coming from the Indic or from the west, from the Mediterranean, and it's loaded with humidity and it's heavy and it tries to make it over the mountains. Well, in simple words, it has to get rid of something,
right,
to become lighter. And it simply starts to, in many regions, rain, but in the Karakoram, it starts to snow. So it really starts snowing heavily as a result of the warmer oceans, which is really weird, right? And all that additional snow on the glaciers in the Karakoram, then results in that advance. So it's a result of climate change. We have some other cases like the west coast of Norway or New Zealand, where some of the glaciers are advancing. So I think the conclusion for the non-scientists is important, that that nature is not black and white, right? There's a lot of gray zone, and that gray is particularly interesting to scientists.
Right.
So to understand the whole picture.
Well, thank you for helping us understand the science behind climate change and the fact that but probably some people might think that all glaciers are shrinking is actually not true, and how interesting that there are some, because of what you just explained, are actually through global warming are increasing in size because there's more moisture in the air, and therefore there is more snowfall, and therefore there is more buildup. And some of the glaciers this way, in a strange way, are actually growing while others somewhere else are shrinking. But moving away a little bit, Ulrich, from the hard science, so to say, and no pun intended here with hard and ice, but looking at how does climate change impact societies and cultures. There must be, when I'm thinking about glaciers and people that have lived near or are somehow impacted by their traditions or by their customs through this change that is happening. How has this impacted? What have you seen as far as societies and their cultures?
Yeah, okay. So climate change has multiple impacts on people and societies, and these impacts come at various scales. So in local communities, also the one that I visited, And this is interesting and kind of dangerous. So glacial recession might cause, for some years, increased flooding, and because the glaciers are melting and you have more water available, and that might lead in some communities in the mountains to flooding for some years. And then later, the glacier, when it really melts back and is very small and is sitting in higher elevations, then the water actually diminishes suddenly, and less water is available, for example, for agriculture and other uses. So the melting glaciers might be sometimes, at least for some years, good news for the locals, because they are in demand of more water for the agriculture, and it's coming from the melting glaciers.
Right.
And of course, also local and regional authorities. And I experienced that in Mongolia, where now the government in the Altai Mountains, is proposing a couple of new dams. So, and these dams will be, you have to fill the reservoir behind the dam, and you use the water for hydropower.
Right.
We need more and more electricity also in the Altai Mountains. And you have to fill the reservoir in the Altai mainly with meltwater from the glaciers.
Right.
And all the measurements right now show that there is more meltwater because the glaciers are melting. But again, the problem is that at one point, it all really turns around, and the glaciers are so small that almost no meltwater will coming down the mountain any longer. And then you look at droughts, for example. And I had one example in Ladakh, which is in the Indian Himalayas, when we visited the village, I think over 10 years ago. So there was a village that was built on a huge alluvial fan. So it's a landform. It's coming sediment that piled up over thousands of years, coming out of the mountains. And Ladakh is more or less a half desert or desert in some parts.
Okay.
So the only way to do agriculture on these alluvial fans that are sitting high above the natural rivers, right, is to tap into the meltwater from the glaciers behind the alluvial fan. So the people constructed really beautiful, sophisticated canal systems that they sometimes built kilometers deep into the mountains and built them next to the glacier. And very simple, the meltwater then feeds into the canals and brings the water to the fields next to their village. Because the glaciers are melting and there was increased meltwater available, the local government said, well, let's extend the agricultural fields around the city or the village, and we can bring in more people, there's a bright future. Well, that all went totally wrong, and exactly when the glacier melted so much that it was impossible to build these canals deeper into the valley. And even if they would have done it, there would not have been a sufficient amount of glacial meltwater available. So the entire project came to a halt, and it was, an unsustainable investment, right? So the whole project had to be abandoned, and that's a really good example of this maybe wrong understanding of how nature works. So first you have more, and then suddenly you have less.
Right.
So again, what we need is scientists, right, who educate local authorities and villagers, right?
Right. Now, I remember that I once served on a master's committee at the University of Montana. It was like 10 years ago or so, and the grad student was like way ahead of his time. He had a particular interest in climate refugees, a term that up to that point I never even heard before, which was so new, and he was so, really cutting edge at the time. In your research, have you come across climate change refugee stories that you can share?
Um, so this is a really interesting term, right? Usually we think about refugees when we think about war, right?
Right, for political reasons more than anything.
For political reasons, and we call these forced migrations.
Right.
Right, and so, but only again to make clear, so climate change refugees, if you want to call them that, migrants that were forced to leave their home area,
right?
They always existed. So when I did my master thesis actually in southern Jordan next to Petra, so I was working in geoarchaeology. So I was part of an excavation project, and a Neolithic settlement had been discovered. So Neolithicum, goes back like 8,000 years. So we would call that the latest Stone Age period, right?
Right.
So that settlement had been discovered, and then we did research there for some years, and the result showed that 8,000 years ago, so the climate had changed slightly to more dryness. So that was bad news for the locals in those days, right? The beginning also of agriculture.
Right.
But in addition to that, because the landscape, the vegetation looked a little bit different, the farmers in those days were already so successful that that the size of their herds, goats and sheep in the area, increased rapidly. And they overexploited their environment. And it seems that then almost ad hoc, many of the settlements had to be abandoned. So that was, that's very typical for our history as humans. There was a combination of a natural event, like increased dryness, plus in this case, an agriculture that was not really adapted to these changes, and they in combination, led to the idea of moving, giving up your home. The same is true for the Dust Bowl in the US, right? You probably know more about it than I do. So that was a combination of several years of droughts and then a failure in farming approaches, and then 3.5 million people in the 30s had to move, right? So one of the examples of mine is definitely, I was a professor in Montana, right, at the University of Montana for 12 years. And you remember her. So one of my students, she was actually a climate refugee. She was hit by Hurricane Katrina in 2005.
Right.
Which is climate change related.
Yes.
And she packed her remaining goods and belongings, right, and threw it in her car. And
she came from the New Orleans region, didn't she?
Yeah, exactly. Yeah, from New Orleans. And,
right.
And she and her husband and her son, drove simply north. And she told me, we didn't know where to stop. We had no plan. We simply said, get out, let's go somewhere.
Right.
And they had experienced several hurricanes, right? And they were tired of it. And they drove north. And she told me that they drove into the mountains. And at one point they said, this is beautiful. Let's stop. And it was Missoula.
Right.
And then she, studied geography and wrote a wonderful thesis. And she would be officially seen as a climate refugee.
Right.
And then nowadays, what we experienced this year and also the last years, the wildfires in California, we had for the first time in history a wildfire that burned over 1 million acres of land. We've never had that before. So California is burning now every year. And obviously the first people moved out of California into the surrounding states. And obviously many of them to Arizona.
Right.
And they even had an impact, what an interesting story, on a recent election, right? So climate refugees, we will see definitely increasing numbers in the future. and local governments have to deal with it. So I think in 2012, I have one number in mind from my class.
Sure.
There were worldwide 32 million people forced to leave their homes, and only because of extreme weather events. So that does not even count other migration, but the climate change related migration, that was in 1 year over 30 million people. And it's only getting worse because we also have population growth.
Right.
In the year 2050, we will probably have 10 billion people living on spaceship Earth instead of 7.5. That's an increase of 2.5 billion people in the next 30 years, sorry.
Right. So what I'm hearing here, and correct me if I'm wrong, is that the term climate refugee is not new, because nature has caused people to change their location of where they lived for quite some time. What is new, perhaps, is the acceleration that is human caused. Is
correct.
That could one say that?
Yeah, that's correct.
Okay. Now, in addition to sustainable cities and urban mobility, what are some of your current challenges in global climate change? And you talked about that a little bit earlier when you were talking about how you found your passion as a glacier researcher. And you said that you started out when you were young looking at sustainable cities, actually. But what are some of the current challenges in global climate change?
So I think, I remember years ago when I was in Montana, and, Al Gore and the IPCC had received the Nobel Prize. And one of my colleagues at Dr. Steve Running, was part of that group. And he was already well known before and became famous overnight. And he gave that one talk at and he presented for most of the talk about scientific facts, of course, right? That's his field. And he talked about also glacial recessions and sea level rise and the increase in the intensity of hurricanes, etc., etc. Was very convincing. And at the very end, he looked at the audience and he said, so when it comes to the science of climate change, so it's an accepted theory nowadays, right? Everybody who would say that climate change doesn't exist would actually say that she doesn't accept science, right? So this is a scientific fact. Climate change is happening. So we have data available. You can always debate the fine-tuning of the climate change and of the data. For example, predictions of future developments when it comes to temperature, they range between 2 and 6 degrees Celsius until 2100. 2 degrees Celsius is already more than what we had in the last 150 years, right? It would be double of the 1 degree. 6 degrees Celsius might be the end of the way we know how to live today. So hopefully that's not happening. But this is what the climate scientists discuss. So the fine-tuning, not that climate change is not happening. Interesting to us is how much will the temperature increase, how many of the glaciers will disappear, etc. But then Dr. Running, he said, we know the scientific facts. And we natural scientists now, we have to hand over, the whole topic of climate change to the social scientists. And much more important now is to focus on, so what will happen to our societies? What will happen to local communities, like the one in Ladakh that I talked about earlier? There's a wonderful case from Peru that I maybe could talk about. So what will happen to these communities? What will happen to entire economies, right? In some countries, when in some African nations that grow coffee as their main crop, when the climate changes and they cannot grow coffee any longer.
Right.
Of course, we can come up with hybrid coffee species, right, that are more adapted to droughts and so forth. But we really have to look at, so what the heck do we do, right? And so from the social sciences, then we have to conclude what will happen, what can we do, and then at the last step, all the scientists, from all disciplines, we can only hand over data to our elected governments and hope that they make the right decisions, right? That's all we can do. But so coming back to that question, that's probably the big challenge today, okay, that based on the physical facts that we have, how huge will be the impact? Then we could talk about resiliency, right? So how can we grow communities and societies stronger? Right. What can Miami do, knowing that the sea level is rising and the beaches are all disappearing? What do you do as a city? How do we funnel huge amounts of money into this building resiliency and becoming again sustainable?
Let's look into the future just a little bit. Will the actions we take today be enough to forestall the direct impacts of climate change, or is it too little, too late?
Yeah, that's a challenging question. So in 2018, right, two years ago, the Intergovernmental Committee on Climate Change, the Intergovernmental Panel on Climate Change, the IPCC, it's a group of the United Nations. They produce the climate change reports, right, in a specific interval. So in 2018, they published a report that concluded that we will reach the threshold of 1.5 degrees of temperature increase by 2030. So that was a big warning. So that's 10 years from now. So the IPCC said if we cannot make sure that the temperature increase is definitely not more than another additional 0.5 degrees Celsius, right? Because we already have a degree. Then we are looking at impacts that are tremendously huge. So entire ecosystems and societies will start to suffer, and they will change. Look at more floods, even larger wildfires, more droughts, disappearance of glaciers and entire mountain systems. So in a way, the IPCC wanted us to wake up, and they told us, look, we are standing as a global society and community, we are standing at the cliff and we are looking down. And the question is, what do we want to do now? And what will our leaders do? And the main question is, how do we change behavior? So how can you and I act in a different way? And I think it's interesting to see how humans function. So for example, we are right now, right? We are living a nightmare of a global pandemic, right? And who would have thought only a year ago that our generation, at least in the United States, living in the United States or in Europe, right, in highly developed industrialized nations, where we are so protected, who would have known that something like that could have such a huge impact on us, on our personal life,
right?
That we will suffer so much pain. So here we are now in the pandemic, and we understand that things can go wrong super fast, right? And the COVID-19 virus is extremely dangerous. So while scientists globally agreed on the fact that COVID-19 must be fought immediately, and with all strength that we have as a global community, that we have to change lifestyles, like staying home, living in your bubble, wearing a mask, and so forth, so that we don't catch the virus. So we learned that even that is difficult for people. So in that small time frame of only, where are we now, 9-10 months into the pandemic, people have a problem in accepting that scientific fact, that this is highly dangerous, and we have to fight it. So now when we bring that back to climate change, global warming is known since the 1950s, by the way. There was a first paper published, and the scientists used the word global warming. There's nothing new to it. That's, almost 70 years ago.
Right.
The ozone hole was discovered, in the 1980s. The Inconvenient Truth movie from Al Gore is from 2006. So we as a society heard and learned about climate change for decades.
Right.
But as humans who cannot even adjust to a pandemic in a couple of months, how can we as a society adjust to climate change that comes at the scale of decades? So for humans, I think that's very difficult to do. We like to live in maybe the past and today and the next weeks, and where do we go on vacation next year? But thinking about, how will the year 2015 look like when my son, will have his own children? So that's difficult. And so I wouldn't say it's too late, right? It's never too late, but we are really at a point where we have to understand that 2030 will be the benchmark. That's the reference,
and that is just a decade away.
That's around the corner.
Right. Now, we are talking about the future and how how this will be different to future generations. But when we think about us right now, will taking action make our lives better or safer? Just sort of immediately, what could you say about that?
Immediately, so that's difficult because again, the whole Earth system is a very dynamic system, and it's extremely complex. So someone actually said a couple of years ago, in an interview, we don't even really know how that ecosystem, little pond in front of our house, in that public park, how that really works. So understanding all the processes that are going on in that pond, that's extremely challenging, right? It's a very complex system. So now we go at large scale and look at the Earth system. The problem is that, the Industrial Revolution dates back, depending on where we go, maybe where it started in Britain, 1750, we go back a couple of hundreds of years.
Right.
And since then, we are emitting greenhouse gases into the atmosphere, and they accumulated, right? And so even if we would stop all emissions into the atmosphere today, the system would still have to deal with the greenhouse gases that are there from these hundreds of years that we are looking at. And so the impacts of our greenhouse gas emissions in the atmosphere, they will continue. It will, if we act today, it will not be better tomorrow. So this isn't how nature works, right? But definitely we have to act today so that, you and my children, right, and their children will have a better life.
Now, when we talk about this, Ulrich, and I really appreciate the sense of urgency here, how can the average person help slow down the impact of climate change? People like you and me and the listeners to this podcast? What are some examples of what we could do?
Well, becoming green, right? That's one of the, the top words in the last decades. Everything has to be green.
Right.
But you know what is actually true?
Well, I really appreciated you shedding a lot of light on the subject of climate change and global warming, and giving us lots of examples from your own research, from your own travels, and also demystifying some of this. And as we just did in the latter part of this podcast, to really sort of bring this back home and to say, while these things are happening and they are unfortunate, here is actually what we could do to cause a change and to make things better. And so I think this was just a wonderful overview of this entire topic, and also a lot of detailed information from you as a scientist that has worked in this field for decades now. I would like to close, Ulrich, with a question that is more personal. Can you tell us a little bit about your passion? What drives you as a person? Not as a scientist so much, but what is sort of your passion in life?
Oh yeah, that's a good one. Why did I become a scientist, right? So I think when I go back to my own history, my own story, and how I grew up in that tiny little village in Northwest Germany and dreamt, about the world, and that has to do also with my parents and my family. I think I was always interested in the health of our spaceship Earth, our blue planet. And when I looked at that famous picture from the 60s, the blue marble looking from space for the first time at Earth, right? Like an alien. I was very touched when I saw that in school, that picture. And I think I developed that passion for saving the world, right? That was my mission. And nowadays, of course, as a dad, right, I'm passionate about the future of my two boys, and I really want them to have the life that I had, because I think I had so far a really awesome life, and I'm very thankful. I want also them to develop that passion for their environment, and I was interested in protecting nature and our livelihoods. And I really believe that we all have to be, stewards of the world that we live in. And here the word sustainability comes to mind, right? So caring about our next generations. So the reason then why I chose to become a scientist is, I believe so, is that passion and the question, so what can I do? And again, I could always vote for the Green Party, but I wanted more. And so becoming a scientist and being a scientist, that kind of enabled me to present strong arguments that are based on facts and that I hand over to decision makers, like to some villagers and the mayor of a small community in the Deccan, India, and that hopefully has a positive impact. So, I think it's an outdated classic idea, right? And I'm over 50 now, I'm getting older, but I really care about our blue planet, a spaceship Earth, that has always driven me.
Well, that's, I think, a good passion to have, and certainly something that is not a selfish passion, but something that will benefit, like you said, your immediate family, your children, to live in the world and to enjoy the things that we have had the opportunity to enjoy. Well, thank you, Ulrich, for your time. today for talking to me. And it's been my pleasure to have an expert in the field to shed some light on the big questions and on some smaller ones that we also tackled. My guest for the last International Voices this year was Dr. Ulrich Kamp, glaciologist and professor of Earth and Environment, chair of the Environmental Studies program in the Department of Natural Sciences at the University of Michigan in Dearborn. As always, thank you all for listening. Those of you who are regularly tuning into International Voices know, being of German descent, I usually end with a German farewell. Dankeschön fürs Zuhören. International Voices is brought to you by Global and Cultural Affairs of Arts Missoula and the Trail 1033. This and previous International Voices podcasts can be found at artsmissoula.org and the Trail 1033.com. If your interests are in global and intercultural education, programming, cultural and global competence, and international affairs, we hope you continue to listen to International Voices in 2021. Be well, be safe, and have a wonderful holiday season and a great start into the new year.